This is a group presentation for Statistics Group Q, including Aaron Johnson, Connor Jones, and Maddie Cranmer. The data we have available is based off the data determined by Rev Clay. Variables we have are the number of criminals per 100,000 people, the number of alehouses per 100,000 people, the number of school attendance per 10,000 people, and the number of public worship per 2,000 people. Clay was attempting to use this data to discuss the relationship between the variables, to show how crime is influenced by the number of alehouses present, the attendance on religious worship, and popular education. The first conclusion Rev Clay made was that ale and beer houses are more associated with an excess of crime than attendance at religious worship or school. The next conclusion Clay made was that it is more common for a deficiency in public education to be accompanied by an excess of crime / number of criminals. Clay believes his data shows that religious attendance has little effect on the number of criminals, stating that the teaching of religious principles has not been promoted correctly at Sunday school. He also discussed what he referred to as the happiest example of the infrequency of crime, Cornwall, a county with a low number of criminals, number of alehouses, and a high number of school attendance and public worship. Monmouth, on the contrary, is deemed the worst of English counties, as it has roughly 4 times the number of criminals and of alehouses than Cornwall, with equal education and a higher religious focus. An interesting point made by Clay is as follows. The liability to fall into crime depends very much on the regularity required in their occupation. The man with whom work or idleness is entirely optional is more exposed to the temptation than the unemployed man who must pursue his work uninterruptedly. This idea suggests that without distractions such as regular or consistent work, people will often be presented with the opportunity to commit crimes or drink, further leading to crimes. In conclusion, Clay believes the number of criminals in a county is dependent on the number of alehouses that infest it, whilst also suggesting that education is inefficient at preventing people becoming criminals, often as a result of drinking. This table shows a simplistic set of data, a summary of all the data available to our team. It includes the mean, median, range, both the upper and lower quartiles, the interquartile range and the variance, and the standard deviation of criminals per 100,000 people, alehouses per 100,000 people, school attendance per 10,000 people, and public worship per 2,000 people. We chose these statistics as it creates a very minimal summary of the data available, allowing us a brief overview of the average value for each variable, the value in the middle of each set of data, both Q1 and Q3. It also shows us measures of variance, including the range between the highest and lowest value and the statistical dispersion that is equal to the difference between the quartiles. The table also shows the variance, which is a measure of how far a set of numbers is spread out, and the square root of this value, or the standard deviation. This question requires a histogram, which are graphs designed to display a frequency distribution, which shows how often each different value in a set of numerical data occurs. This slide shows a histogram based off the number of criminals per 100,000 people. While it initially appears to be a normal distribution, we decided it was most likely to be an edge-peak distribution due to the presence of a large peak at one tail. This is often caused by faulty construction of the histogram. This is a simple bar chart designed to display the average number of criminals per 100,000 people for each region present in the available data. To determine this, each region must be identified, which gave us 9 regions. We then calculated the mean, the sum of the number of criminals per 100,000 people in each country in a determined region, divided by the number of values per said region. Once we had a mean value for each region, we used a simple Excel function to produce the bar chart. To answer this question, we first determined what correlation was. Correlation is a measurement of the degree of association between two continuous variables, shown as the correlation coefficient and referred to as R. The correlation coefficient lies between -1 and 1, or perfect negative correlation and perfect positive correlation. To determine the correlation coefficient for number of criminals per 100,000 people against the other three variables, the first step was to plot a simple scatter graph by selecting the necessary values for the x-axis, number of criminals, and the y-axis, or the variable. Excel created the scatterplot graph and had a tool that presents linear trendline, along with the line equation and the r-squared value. To determine the r values, we simply found the square root of r squared. From our data, we determined the correlation coefficient for the number of criminals against number of alehouses is 0.531. This shows a moderately strong correlation between criminals and alehouses, as it is above 0, which would suggest no correlation, and close to 1. The number of criminals increases as the number of alehouses do. The correlation coefficient of the number of criminals against the number of school attendants is minus 0.288. A slightly negative value showing there is little correlation between these two variables, but what correlation there is indicates that as the number of school attendants increases, the number of criminals decreases. Finally, the correlation coefficient of number of criminals against number of public worship is minus 0.0636, a value close to 0, which suggests there is no linear relationship between the two variables and that the number of criminals is hardly affected by the number of public worship at all. For this question, we determined probabilities. The first probability was straightforward: the number of counties with more than 150 criminals per 100,000 people over the total number of counties, or 17 out of 35. The second probability was more difficult to determine as it involved the union of two individual events. The first step to it was identifying the counties that experienced the first event. There is a public worship rate of less than 900 per 2,000 people. We identified 26 counties that fit this criterion, and from these 26, only 14 of them experienced the second event. They have more than 150 criminals per 100,000. This gave us a probability of 14 over 26, which further simplifies to 7 over 13. The final probability to identify was the probability that a county with more than 150 criminals per 100,000 people also has less than 900 public worship per 2,000 people. The number of counties that has more than 150 criminals per 100,000 people is 17, and of those 17 counties, 14 of them had less than 900 public worship per 2,000 people. This gives us a probability of 14 out of 17. To reach our conclusions, we used different techniques than Clay. It is likely that Clay read the data available and made his conclusions based on the data alone. However, thanks to advanced IT packages available, such as Excel, and numerous sources of knowledge based on statistical analysis, we can use techniques such as working out probability, determining correlation coefficients, providing statistical t-tests, histograms, and scatter graphs to give us values that we can then use to prove and validate our conclusions. We believe that our results do agree with those of Reg Clay. There is multiple similar conclusions that we can reach that mimic those found in the journal. For example, our data allowed us to determine the coefficient correlation between the number of criminals against religious attendance. This value was close to 0, implying there is little to no correlation between the teachings of religion and the number of criminals. This conclusion was also reached by Clay when he declared the teachings of Sunday schools were not accurately promoting satisfactory religious knowledge. This is further evident by our work with probability. We determined the probability that counties with public worship rate of less than 900 also had more than 150 criminals per 100,000 people was 7 over 13. From this, we can infer that 6 over 13 counties with public worship rate less than 900 had less than 150 criminals per 100,000 people. This is roughly equal, showing how public worship has minimal relationship with criminals. The correlation coefficient of the number of criminals against number of alehouses also reached a similar conclusion to that of Clay, as a positive correlation shows how the presence of alehouses has an evident effect on the number of criminals. Due to the negative correlation coefficient between number of criminals and school attendance, we can infer that as the rate of education increases, the number of criminals in a county decreases, and we believe this could be helpful to the UK government. In order to reduce future crime, we believe there needs to be a large push on education, specifically in areas that have low school attendance and a high number of criminals, such as Hereford, with 630 school attendance per 10,000 people, yet 213 criminals per 100,000 people, and Warwick, with 770 school attendance per 10,000 people, yet 183 criminals per 100,000 people. The number of school attendance in both instances is below average, while the number of criminals remains high. We believe this will ensure that less people are enticed by the temptations that crime presents, providing them with more regularity and order. This will in turn prevent crime in 2023 and beyond.